It feels like in just a few short years, AI has gone from something out of science fiction to a tool millions of us use every single day. These large language models, they seem to have just exploded out of nowhere, right? Suddenly they're writing poetry, coding software, really changing the world. But here's the thing, this overnight revolution was actually decades in the making. So, what was the secret?
I mean, that's the question on everyone's mind. It really does feel like a big bang moment in tech. All of a sudden, these models can write, they can reason, they can have conversations. But this incredible leap forward, it wasn't just one single thing.
The truth is, that Big Bang was more like a chain reaction, set off by four absolutely critical breakthroughs. In this explainer, we're going to unpack every single one of them to really understand how we got here. So let's start at the very beginning. Our story kicks off with a really fundamental problem. See, before 2017, AI models had a terrible memory. I mean, seriously, when they were trying to process long sentences or paragraphs, they'd basically forget what the beginning said by the time they got to the end. And this is where our first breakthrough comes into play, the attention mechanism. The best way to think about it is like this. You know how you highlight the most important sentences in a textbook? You don't try to memorize the whole book at once, right? You pay attention to the key stuff. Well, this technique basically let models do the same thing. Weigh how important different words are, no matter how far apart they were in a sentence. Now, the core idea had actually been floating around since the 90s, but the game truly changed in 2017. A paper came out with this audacious title, Attention is All You Need, and it did exactly what it said on the tin. It introduced the transformer model, which didn't just use attention, it was built entirely on attention. It threw out all the old clunky architectures. This one paper, this one idea, it was the spark that lit the fuse for the entire LLM revolution. So once the transformer was out in the wild, it started to evolve, and fast. Researchers realized this amazing new architecture could actually be split and specialized for different jobs. And that leads us straight to our second big breakthrough, a kind of blueprint for building pretty much all modern LLMs. So two distinct paths started to emerge. Think of it like this. On one side, you have the encoder path. This is your detective, a model like BERT. It looks at the entire text at once, forward and backward, to understand really deep context. It's great for analysis. But then you have the decoder path. This is your storyteller. And yeah, think GPT. It looks at what's already been written, and its only job is to predict the very next word to keep the story going. That storyteller path, that is the direct ancestor of the chatbots we all use today. But okay, how do you actually teach these huge models efficiently? Well, a paper in 2018 gave us the perfect recipe. Step 1, you pre-train a model by just letting it read a giant chunk of the internet. It's like sending it to the library to get a general education. Then, step 2, you fine-tune it on a much smaller specific data set for the job you want it to do. The absolute genius here was that you didn't have to build a new brain from scratch every time. This made everything so much faster and more accessible. So, we've got the architecture and we've got the training recipe. The next breakthrough, well, it wasn't some clever new algorithm. It was more of a brute force discovery. Researchers found that just making these models bigger didn't just make them a little bit better, it made them fundamentally different. It unlocked all these new abilities that nobody had explicitly programmed into them. This discovery kicked off a kind of arms race to build the biggest models possible. But then, in 2022, a paper called Chinchilla dropped a total bombshell with this one quote. It basically suggested that the entire field was thinking about scale all wrong. It wasn't just about the size of the model. And the proof was, well, it was kind of startling. Just look at this. The Chinchilla model, with less than half the horsepower of the massive GPT-3, was consistently outperforming it on key benchmarks. The smaller model was winning. How on earth was that possible? The answer was data. A whole lot of data. Chinchilla was trained on 1.4 trillion tokens of text. That's more than 4 times the data GPT-3 got. This discovery gave us the modern scaling laws and proved that peak performance isn't just about model size. It's about the ratio of model size to the amount of training data. Turns out, you absolutely need both. Okay, so we have a powerful, scaled-up model that's been fed a ton of data. We're done, right? Well, not quite. There's a huge problem. An AI that's only trained to predict the next word can be kind of random. It can be unhelpful or even toxic. And that brings us to the final and maybe the most important breakthrough, teaching AI how to be a useful and safe partner for people. You see, a raw model is like a wild genius. It's incredibly powerful, but it's totally unpredictable. So, this final step is all about alignment. It's the whole process of shaping that raw intelligence so its behavior becomes helpful, harmless, and basically aligned with what we humans actually want. This is how you turn a simple text predictor into a real assistant.
The key technique here has a bit of a mouthful of a name: reinforcement learning from human feedback, or RLHF. But it's actually a really clever three-step dance. First, you just show the AI some good examples of conversations. Then, you have humans act like judges, ranking the AI's different attempts to answer a prompt from best to worst. This teaches a separate reward model what humans like to see. And finally, that reward model becomes a coach, training the main AI to give answers that it knows will get a high score. This whole process, it's the secret sauce that makes chatbots so incredibly helpful. So, there you have it, the whole journey, from a model that couldn't even remember the start of a sentence, all the way to the powerful AI we have today. And it was all built on these 4 pillars: attention, a flexible blueprint, massive scale, and finally, human alignment. Take away any one of them, and we wouldn't be where we are today. And that really brings us right up to today. After all these incredible breakthroughs, we've finally built machines that can understand and follow our instructions. Which leaves us with the great, unanswered question that's going to define our future. The one right here on the screen. What instructions should we give them next? Thanks for joining this explainer.